Good evening, students. Today we shall discuss trigonometric equations. Trigonometric equations. What is a trigonometric equation? An equation which contains one or more trigonometric functions is called a trigonometric equation. An equation involving one or more trigonometric function is called a trigonometric equation. For example, if I take 2 sin x minus 1 is equal to 0, this is a trigonometric equation. As you can see, it's an equation which contains a trigonometric function. Then, if I take cos square x minus 2 sin x plus 1 equal to 0, this is also a trigonometric equation. Any equation which contains one or more trigonometric function is called a trigonometric equation. These are few examples of trigonometric equations. Then, the solution of a trigonometric equation. The value of x, in this case x is the variable here, the value of x which satisfies this equation is called the solution of that equation. So, here for example in this case x equal to pi by 6 is a solution. How do I know that x equal to pi by 6? So, from here I can write 2 sin x is equal to 1. I am bringing minus 1 to this side. So, then sin x is equal to 1 by 2. Sin x equal to 1 by 2 means x equal to pi by 6. X equal to pi by 6 is one of the solutions. So, after pi by 6 I can take 5 pi by 6 also. 5 pi by 6 is nothing but 150 degree. Sin 150 degree is also equal to 1 by 2 because sin 150 is nothing but 180 minus 30. Sin 180 minus theta is equal to sin theta. So, sin 150 degree is also equal to 1 by 2. And further, as you know, since these are periodic functions with period 2 pi, you keep on adding 2 pi to it, all those will be solutions. So, that means for a given trigonometric function, if there is one solution, then there are infinitely many solutions. If there is one solution, I repeat, for a given trigonometric equation, if there is one solution, if you can find out one solution, then we can find infinitely many solutions. How? See, here I have got pi by 6. Now, I will keep on adding 2 pi to it, pi by 6 plus 2 pi plus 4 pi plus 6 pi plus 8 pi plus 10 pi, etc. It's a never ending process. So, all those will be solutions, right? So, at all those points sin x will be equal to 1 by 2. Okay. So, in this way we can find the solution. Then there are two kinds of solutions. One is the principal solution and the other one is the general solution. Principal solution means the value of that x which are in this interval, that x should be greater than or equal to 0, x is greater than or equal to 0 but less than 2 pi. The solution set from this interval, the solutions which are there in this interval, those solutions are called principal solutions. Solutions which lie in between 0 and 2 pi, those are called the principal solutions. Okay? With the help of those principal solutions, we can find all the other solutions also, like what I said earlier, go on adding 2 pi, we will get all those solutions. All those solutions put together we can write in terms of an integer n. Those are called general solutions of trigonometric equation. Now, even though in our textbook we have principal solutions as well as general solutions of trigonometric equations, but that general solutions is removed from this present syllabus only for this year. As you know, 30% of the syllabus is reduced. So, in that this topic is also one of them. General solutions is removed, so you need not worry about general solutions, but equations are there and principal solutions are there. So, I will just discuss how to find the principal solutions of the trigonometric equations. Okay? So, I repeat, what is a trigonometric equation? An equation which involves one or more trigonometric function is called a trigonometric equation. Then, solution, the solutions of a trigonometric equation which lie in between 0 and 2 pi, that solution, that value should be greater than or equal to 0 but less than 2 pi, then such solutions are called principal solutions. Okay? And the set of all possible solutions put together, those are called general solutions. However, we are not going to discuss them here. Okay. So now let me take some problems. Let me start with this itself. Question is, find the principal solution of the following equations. Find the principal solutions of the following equations. Let me find out the principal solutions. Okay, I'll take tan x minus root 3 is equal to 0. Okay, tan x minus root 3 equal to 0. I want to find the principal solution for this. From this equation, I can write tan x is equal to root 3. Tan x is equal to root 3 means, what is the value of x? X is equal to pi by 3, 60 degree. Tan 60 is root 3. Okay, tan x will be equal to root 3 once in the first quadrant, and again it will also be root 3 once in the third quadrant, because tan x is positive in the first quadrant and also in the third quadrant. What is that value? Because that also will lie in between 0 and 2 pi, right? So pi by 3 plus pi means 4 pi by 3, 240 degree. Tan 240 degree is also equal to root 3. So the principal solutions of this equation are pi by 3 and 4 pi by 3. Next question. Secant x is equal to 2. This is also a trigonometric equation. For this, we have to find the principal solutions. Secant x equal to 2. Secant x equal to 2, if you can also write cos x is equal to 1 by 2, because secant x is the reciprocal of cos x. When secant x is 2, cos x will be equal to 1 by 2. Now cos x is equal to 1 by 2 for what values of x? For what values of x? Cos x is equal to 1 by 2. That we shall check now. So cos x is 1 by 2 means x value 60 degree, right? That means pi by 3. Okay. So in first quadrant pi by 3, in second and third quadrant not possible because there cos x is negative. In fourth quadrant again cos x will become 1 by 2. What is that value? So that is nothing but 360 minus 60, 300. 300, how can I write 5 pi by 3. Okay. So cos 5 pi by 3 is also equal to 1 by 2. So these two are the principal solutions of this. Then 2 sin x plus 1 is equal to 0. 2 sin x plus 1 equal to 0. From this we can write 2 sin x is equal to minus 1. Sin x is equal to minus 1 by 2. Sin x is equal to minus 1 by 2. Okay. Sin x is equal to minus 1 by 2. What is the value of x? Now you might think, sir, if I write x equal to minus pi by 6, is it not a solution? It is a solution, yes, correct, because sine of minus pi by 6 in terms of degrees 30 degrees. Sine of minus 30 is nothing but minus sine 30, you get minus 1 by 2. But the question is to find the principal solutions, not just solutions I have asked. They have asked us to find the principal solutions, and minus pi by 6 is not a principal solution. What did I say? Principal solution means that value of x should be greater than or equal to 0 but less than 2 pi. It should be greater than or equal to 0 but less than 2 pi. This minus pi by 6 does not lie in this interval. Okay. So I cannot write minus pi by 6 as the solution. Well, sin x is negative. Sin x is negative either in the third quadrant or in the fourth quadrant. So in the third quadrant, when it will be minus 1 by 2. So 180 plus 30, right? 210 degree. 210 degree in terms of radians, 7 pi by 6, right? Sin 210 I can write as 180 plus 30. Sin of 180 plus 30, third quadrant negative. So you get minus sin 30, that's equal to minus 1 by 2. So 7 pi by 6 is one value. And then 2 pi minus pi by 6. 2 pi minus pi by 6, 11 pi by 6. 11 pi by 6 is also a principal solution because sin 11 pi by 6. 11 pi by 6 means 30 into 11, 330 degree. Sin 330 degree, I can write 330 degree as 360 degree minus 30 degree. Sin 360 minus theta is equal to minus sin theta. That means you get minus sin 30, that's equal to minus 1 by 2. So 7 pi by 6 and 11 pi by 6 are the solutions, are the principal solutions of this trigonometric equation. Okay. Next. Root 3 cosecant x minus 2 is equal to 0. Root 3 cosecant x minus 2 equal to 0. We have to find the principal solutions for this. From this equation I can write root 3 cosecant x is equal to 2. Cosecant x is equal to 2 by root 3 and sin x, it is the reciprocal of cosecant x, that's equal to root 3 by 2. Sin x is equal to root 3 by 2. Then what are the principal solutions for this? So sin theta will be equal to root 3 by 2 when theta equal to 60 degree, obviously. Pi by 3 and 2 pi by 3 also. That is at 120 degree also sin theta will be equal to root 3 by 2. 120 degree. Sin 120 degree is equal to sin 180 minus 60, which is equal to plus sin 60, that's equal to root 3 by 2. So pi by 3 and 2 pi by 3, these are the two principal solutions of this equation. Okay, next. Cot x is equal to root 3. Cot x equal to root 3, we have to find the principal solution for this. Cot x equal to root 3, if you want you can write tan x equal to 1 by root 3, or else directly also you can find, no problem. Tan x is equal to 1 by root 3. Tan theta, when it will become 1 by root 3? When theta is equal to 30 degree. Tan 30 degree equal to 1 by root 3, right? So x is equal to pi by 6 and another value is pi plus pi by 6. Once in the tan x will be positive, once in the first quadrant and again in the third quadrant. So in the third quadrant pi plus pi by 6, which is 7 pi by 6. So these two are the principal solutions of this equation. Next, secant x equal to root 2. Secant x equal to root 2 means cos x is equal to 1 by root 2. Cos x is 1 by root 2. Then what is the solution? What is the principal solution for this? Cos theta will be 1 by root 2 when theta equal to 45 degree. Hence x is equal to pi by 4 here. 45 degree in terms of radians, pi by 4. This one value, cos x is positive in the first quadrant and also in the fourth quadrant. So I need to find out one more value which is in the fourth quadrant. So that will be 2 pi minus pi by 4, which is 7 pi by 4. Okay. So cos 7 pi by 4 is also equal to 1 by root 2. Okay. Then cosecant x is equal to minus root 2. Cosecant x is equal to minus root 2. That will imply that sin x is equal to minus 1 by root 2. Sin x is equal to minus 1 by root 2. So the principal solution, sin x is negative, means x should be either in the third quadrant or in the fourth quadrant. So we will get one solution in the third quadrant and another solution in the fourth quadrant. So what is that solution? Pi plus pi by 4. One is 5 pi by 4, other one is 7 pi by 4. That is 225 degree and 315 degree. 225 degree, sin 225 if you want to find out, what do? We will write 225 degree as 180 plus 45. Sin 180 plus 45, third quadrant negative, so you get minus sin 45 degree, that's equal to minus 1 by root 2. Then 7 pi by 4, that means 315 degree. Sin 315 degree equal to 360 minus 45. Sin 360 minus theta equal to minus sin theta, so minus sin 45. That will also give you minus 1 by root 2. Okay, next. cos 4x is equal to cos 2x. Cos 4x is equal to cos 2x. Let us see how to find a solution for this. I will bring cos 2x to LHS. So you get cos 4x minus cos 2x equal to 0. This looks like cos C minus cos D. What is cos C minus cos D? Cos C minus cos D is equal to minus 2 sin C plus D by 2 into sin C minus D by 2. C plus D by 2. Minus 2 sin C plus D by 2. 4x plus 2x, that is 6x by 2, which is 3x, into sin C minus D by 2. 4x minus 2x is 2x by 2 is sin x is equal to 0. This will imply that, say, when this product is 0, either this is 0 or this is 0, because minus 2 cannot be 0. Either this is 0 or this is 0 or both are zeros. So this implies that sin 3x is equal to 0 or sin x is equal to 0, right? If sin 3x is equal to 0 means what are the possibilities? 3x could be 0, or it could be pi, or it could be 2 pi, or it could be 3 pi, 4 pi, 5 pi. Okay? Then sin x equal to 0 means x is equal to either 0 or pi. Now 2 pi is not possible because I am finding the principal solution here. Principal solution means x should be x should be greater than or equal to 0 but less than 2 pi. Now you might ask me, sir, then why did you write a 2 pi, 3 pi, 4 pi, 5 pi? Okay. See, here I am finding 3x value. 3x can be 2 pi, 3 pi, 4 pi, 5 pi, because if I take all this, now what happens to x? You just observe. You divide all of this. Okay. I'll write here. Okay. So we have got the solution as 3x is equal to, I wrote 0, pi, 2 pi, 3 pi, 4 pi and 5 pi. 6 pi I cannot write. Then I'll divide this by 3. 3x equal to 0 means x is equal to 0 by 3, that is 0 itself. Here you get pi by 3, 2 pi by 3, 3 pi by 3 means pi, then 4 pi by 3, 5 pi by 3. Observe that all these will lie in this interval. Next, if I have to write 6 pi. There if I divide by 3, I am going to get 2 pi, but 2 pi is not included here. 2 pi is excluded. Only values x greater than or equal to 0 but less than 2 pi. So 2 pi I cannot write. Hence, these are the solutions. Or here you have 0 and pi. That is also included here. So no need to write them again. Hence, these are the principal solutions for this equation, cos 4x plus cos 2x equal to 0. Next question, cos 3x plus cos x minus cos 2x is equal to 0. Okay. So it's not that you are asked to prove that this is equal to 0. That's not the thing. They have given that equation. So you have to find out for what value of x this is true, right? So we want to find out the principal solution. Cos 3x plus cos x. Between these two, I will use cos c plus cos d formula. Cos c plus cos d, as we know, it is equal to 2 cos c plus d by 2 into cos c minus d by 2. So 2 cos c plus d by 2, 3x plus x, 4x by 2, that is 2x, into cos c minus d by 2, c minus d, 3x minus x, that is 2x by 2, that is x, minus cos 2x is equal to 0. So I will take cos 2x as common here. Then what will remain? 2 cos x minus 1 is equal to 0. So when this product is 0, either this factor is 0 or this factor is 0. So this will imply that cos 2x is equal to 0 or 2 cos x minus 1 is equal to 0. Cos 2x equal to 0, cos theta, when it will become 0? Whenever theta is an odd multiple of pi by 2. So this implies that 2x is equal to pi by 2, or it could be 3 pi by 2, 5 pi by 2, 7 pi by 2. Okay, 9 pi by 2 also it is true, but I am finding the principal solution. 2x equal to 9 pi by 2 means x will be equal to 9 pi by 4. That 9 pi by 4 is not in that interval. What is that interval we want? X should be greater than or equal to 0, less than 2 pi. Okay, so this is what I consider. Now I'll divide by 2. When I divide by 2, x is equal to pi by 4, 3 pi by 4, 5 pi by 4 and 7 pi by 4. Okay, coming to this now. 2 cos x minus 1 equal to 0. From this I can write 2 cos x equal to 1, cos x equal to 1 by 2. That means x is equal to pi by 3 or sorry, or 5 pi by 3 in the fourth quadrant. Okay, these are the principal solutions of this equation. Next question. Question is same, only one question could be asked here, that is find the principal solution. Sin 2x plus cos x is equal to 0. Sin 2x plus cos x is equal to 0. Okay, sin 2x, I will write sin 2x as 2 sin x cos x plus cos x is equal to 0. I will take cos x as common here. So, if I take cos x as common, we are left with 2 sin x plus 1 equal to 0. Again, very similar to the previous case. When the product is 0, either the first factor is 0 or the second factor is 0. So, this will imply that cos x equal to 0 or this 2 sin x plus 1 is equal to 0. So, cos x equal to 0 means what are the possible values of x? X is pi by 2, 3 pi by 2, that is all. I cannot write 5 pi by 2 because 5 pi by 2 is not there in that interval. Or 2 sin x equal to minus 1, sin x is equal to minus 1 by 2. Sin x is equal to minus 1 by 2 means value of x is 7 pi by 6. In an earlier problem also we had solved 7 pi by 6 sin 210 degree and 11 pi by 6 330 degree. These are the two solutions, 7 pi by 6 and 11 pi by 6. Okay. Next question. Secant square 2x is equal to 1 minus tan 2x. Secant square 2x is equal to 1 minus tan 2x. Okay. I will write secant square 2x. Secant square theta can be written as 1 plus tan square theta, right? So, I am writing this as 1 plus tan square 2x. Bring these two terms to LHS. Minus 1 plus tan 2x equal to 0. Secant square theta is equal to 1 plus tan square theta. I am writing secant square 2x as 1 plus tan square 2x. Then I am bringing these two terms to LHS. This is what we get. 1 gets cancelled. So, we have tan square 2x plus tan 2x equal to 0. I will take tan 2x as common. Then we have tan 2x plus 1 equal to 0. Tan 2x plus 1 equal to 0. So, this implies that either tan 2x equal to 0 or tan 2x plus 1 equal to 0, which means tan 2x is equal to minus 1. Okay. Tan theta is 0 whenever theta is a multiple of pi, that is at a 0, at pi, at 2 pi, 3 pi, 4 pi, etc. So, this implies 2x value 0 is one of those values. Then I can write pi, I can write 2 pi, I can write 3 pi. 4 pi I cannot write because, yeah, I can. 4 pi is a solution but not a principal solution. Okay. But 3 pi is, because 2x will be equal to 3 pi, that means x will be equal to 3 pi by 2, right. Then tan 2x equal to minus 1 means minus 1, when it will be minus 1? once in the second quadrant and once in the fourth quadrant. So that is pi minus pi by 4. 3 pi by 4 is 1, and then 2 pi minus pi by 4, which is equal to 7 pi by 4. Then add 2 pi to this, 3 pi by 4 plus 2 pi, 11 pi by 4, and 7 pi by 4 plus 2 pi, that will be 15 pi by 4. Okay. Now you might be thinking, sir, how do you know all these things? How do we write this? So, you know, tan 2x is minus 1. Minus 1 means tan theta negative in second quadrant and fourth quadrant, right? So, in the second quadrant 135 degree, tan 135 degree is equal to 180 minus 45, second quadrant negative minus tan 45 degree, so you get minus 1. And then fourth quadrant tan 360 minus 45, 360 minus 45, 315 degree, tan 315 is also minus 1, because 315 degree we are writing it as 360 minus 45, tan 360 minus theta is equal to minus tan theta, so that will give you minus tan 45 degree, which is equal to minus 1. Okay, I got these two, right? 3 pi by 4 and 7 pi by 4. After that, because it is 2x, okay, say x lies between 0 and 2 pi means 2x should lie between 0 and 4 pi, right? Multiply this by 2, we get 0 here and 4 pi there. So what to do then? Then for this add another 2 pi. For this also add 2 pi. 3 pi by 4 plus 2 pi will give you 11 pi by 4. 7 pi by 4 plus 2 pi will give you 15 pi by 4. Now divide by 2. X is equal to 3 pi by 8, 7 pi by 8, 11 pi by 8 and 15 pi by 8. Okay. Here 2x is equal to 0 pi, 2 pi, 3 pi, etc. So x is equal to 0, pi by 2, pi, 3 pi by 2. These are the principal solutions for this trigonometric equation. Okay. Next question. Sin x plus sin 3x plus sin 5x is equal to 0. Sin x plus sin 3x plus sin 5x is equal to 0. Okay, here I will consider these two. Sin x plus sin 5x plus sin 3x is equal to 0. Now I will consider these two. Sin c plus sin d formula I will use. What is sin c plus sin d? Sin c plus sin d is equal to 2 sin c plus d by 2 cos c minus d by 2. 2 sin c plus d by 2, x plus 5x, that is 6x by 2, which is 3x, into cos c minus d by 2, x minus 5x, that is minus 4x by 2. Cos of minus 2x is same as cos 2x, plus sin 3x equal to 0. So we shall take sin 3x as common here. If I do that, then we are left with 2 cos 2x plus 1 equal to 0. Either this is 0 or this is 0. If this is 0, so that means sin 3x equal to 0, or 2 cos 2x plus 1 equal to 0. Okay, 3x equal to 0 means the solutions are 3x is 0 or pi or 2 pi, 3 pi, 4 pi, 5 pi. 6 pi I cannot write because 3x equal to 6 pi means x will be equal to 2 pi, then it will not be a principal solution. Then that means x is equal to 0, pi by 3, 2 pi by 3, 3 pi by 3 means pi, 4 pi by 3 and 5 pi by 3. 2 cos 2x equal to minus 1 means cos 2x is equal to minus 1 by 2. So 2x is equal to, cos theta is negative in the second and third quadrant, right? Second quadrant cos theta minus 1 by 2, that is at 120 degree. So 2 pi by 3. Then in the third quadrant cos 180 plus 60, that is cos 240, 4 pi by 3. Okay. Add 2 pi to this, 8 pi by 3 you get. And add 2 pi to this also, 10 pi by 3. then x will be equal to pi by 3, 2 pi by 3, 4 pi by 3 and 5 pi by 3. Okay. These are the principal solutions of this trigonometric equation. Okay. Two cos square x plus 3 sin x is equal to 0. 2 cos square x plus 3 sin x equal to 0. I will write cos square x as 1 minus sin square x plus 3 sin x is equal to 0. So, 2 minus 2 sin square x plus 3 sin x equal to 0. I will multiply by minus sign. So, you get 2 sin square x minus 3 sin x minus 2 equal to 0. This is like a quadratic equation. It is a quadratic equation in sin x. See, it is as good as if I take sin x as y for our for simplicity sake. Just for simplification purpose, I am taking sin x as y. Okay. So, it will be 2y square minus 3y minus 2 equal to 0. So, it is a quadratic equation. Let us factorize this. When we multiply, we should get minus 4y square, and when we add, we should get minus 3y. So, that means minus 2y square minus 4y plus y minus 2 equal to 0. So, 2y if I take common, you will have y minus 2 plus 1 into y minus 2 is equal to 0. So, you get 2y plus 1 into y minus 2 equal to 0. Okay. Now, replace that y with the sin x, or directly here also if you can factorize it. So, it will be 2 sin x plus 1 into sin x minus 2 is equal to 0. Okay. Now, this product is 0 means either this is 0 or this is 0. So, if this is 0, 2 sin x plus 1 equal to 0, sin x is equal to minus 1 by 2. When sin x is equal to minus 1 by 2, the solution is 7 pi by 6 and 2 pi minus pi by 6, that is 11 pi by 6. 7 pi by 6 and 11 pi by 6. Okay, these are the two values. And here what happens? Or this, if this is 0, I am talking about sin x equal to 2. Sin x is equal to 2. Is it possible? No, it is never possible. You put any value for x, sin x will never be equal to 2. We have seen this in yesterday's class also, that if you look at the graph of sin x, that graph will never go above 1 because the maximum value of sin x is 1. So, how can I get 2 then? Okay. You put any real value of x, whatever you want, you substitute for x, you are never going to get sin x is equal to 2. Sin x value, its range is minus 1 to 1. So, its maximum value is plus 1. So, here I have to write which is not possible, right. So, which is not possible. Then you might ask me, sir, what is the question? What is the answer for this question? Should I write which is not possible? No, only this is not possible. This is very much possible. So, the principal solution of this trigonometric equation is R 7 pi by 6 and 11 pi by 6. Okay? Okay, students, with this I will stop this class. And with this we have come to the end of trigonometric equations and as well as trigonometric functions. So, this is the end of this chapter. Watch all the videos and refer textbook. I solved much more problems than what is there in the textbook. You solve all of those and remember all these formula, which will be useful for from the exams point of view also, from the subjects point of view also. Thank you.